So, good afternoon, everyone. My name is Mr. Adeyeye Adeolupita. I am your favorite tutor, Kakstov Academy. So, today we want to look at fundamental quantities. Then from there, I will enter dimensional analysis. So, what are fundamental quantities? These are quantities from which other quantities are being derived. And we have about 7 of them. So every other quantity depend on the fundamental quantities. They will get the derivation from the fundamental quantities. So example of fundamental quantities, we have the length. So I will put the unit and the dimension here for you. So the unit for length is meters. And the symbol you can see for meter is M. While the dimension for length is L. You can see that we use capital letter, and we use the letter of the first letter of the word length. The first letter is what we are going to be using for the dimension. Then the next one is mass. The unit for mass is kilogram, which is kg, while the dimension for mass is capital letter what? M. Okay, thank you. Then the third one is time. We have time. Then the unit for time is seconds. So you can see we have S in bracket. Then the dimension for time is going to be T, the first letter of time. While we also have current. The unit for current is ampere, which is A. But different people use different dimension for current. So you can see we have the ampere, which is the first letter of the unit for current, ampere, A, the A from A. Then we have C, which is also the first letter of the word current. Then we have capital letter I, which is the first letter of the unit, which is the unit for current. So you can use A, you can use C, or I. Now let's go into dimensional analysis in proper. So anytime you are asked to find the dimension of any physical quantity, those physical quantities are going to be derived quantities. And what are derived quantities? These are quantities that are obtained from fundamental quantities. So they depend on the fundamental quantities. So we can say they are dependent, while fundamental quantities are independent. Okay? So area, don't forget, the unit for area is always meter square, kilometer square, centimeter square, and so on and so forth. So unit of area is always in what? In square. So, but because we use meters for length here, we didn't use centimeter, we didn't use kilometer. So anything area is going to be based on what? On meter. So what's not going to be the unit of area? We are going to have meter square. But we are not dealing with units. So you should be able to move from unit to transcend from unit to what? To dimension. So what's the dimension for length? Whose unit is meter? Meter. That's what? L. Now, what's now going to be the dimension for area? Whose unit is meter square? That's now going to be what? Just change this meter square now to what? To L. So we are going to have L what? L square. So it's as simple as that. Then if you go to volume, what's the unit for volume in terms of meter? This is going to be meter cube. So definitely the dimension for volume is going to be L raised to the power of 3. Although there are some dimension where you will need the knowledge of indices, even the knowledge of simultaneous equations. We are going to get there soon. Then what's the dimension for density? Density. Now here, we have to know the formula for density so that you'll be able to break it down until you reach the fundamental quantities. So what is density? Density is equal to mass over what? Good. You got it. Over volume. So we have mass over volume. So what is mass? So let's break it down now. We have to break it down till we get this. We must get our expression in terms of LMT or ACI. So what is M? M is what? M stands for mass. And what is the dimension for mass? That's what? M. Then volume. What is the dimension for volume? Just transfer. Dimension for volume is what? L raised to the power of 3. Now let's apply indices. Indices. So anything raised to the power of minus is 1 over that thing. So if you break this down, this one is the same thing as m times 1 over L raised to the power of 3. So if our indices comes in, this is now going to be m. You don't need to change m. Sorry, capital M. You don't need to change m at all. Then times. We don't want any fraction at all. So we have to apply the law of indices to bring L raised to the power of 3 up. So what do? This is going to be L raised to the power of minus 3. So if you combine the two together, we have what? M L raised to the power of minus 3. So that's the dimension for density. Now we move to work. What is the dimension for work? So you also get the dimension for work from the formula. What's the formula for work? Work is force times distance. You can see that you must be well acquainted with the formulas for each of these physical quantities. Now, force and distance. Now, if you check very well, you discover that the only quantity here, the only quantity between force and distance that is already in the fundamental quantity is what? Is distance. So we will not have much problem with distance because distance is the same thing as what? As length. But force is not fundamental. So you have to look for another formula for force, which will help us break into the fundamental quantities. So what is force? What is force again? Force is what? Mass times what? Acceleration. Now this mass acceleration is only force. So don't forget that we still have times what? Distance. So you include that again. Times what? Distance. So and now if you look at this again, you will discover that we now have mass also as what? Fundamental. So the only one that is not fundamental here again is what? Acceleration. So you keep breaking. But before you break acceleration, let's write out the dimension for mass. What is mass? That's what? M. So then what is acceleration? Acceleration is what? Velocity over what? Over time. But if you don't want to disturb yourself that much, at least you know the unit for acceleration. So what's the unit for acceleration? That's meter per second square. So I can write meter, but please be very careful so that you will not mix the meter with what? With m, which is mass. So you can see that I use small letter for what? For meter. Then meter per second square, this ms raised to the power of minus 2. Put in bracket for you to know that you have not converted it to what? To dimension. Okay, it's still in unit. Then your distance. I told you that distance is what? Is length. So we use what? L. Then you move on. This is going to be m times. Now let's convert to fundamental quantity to our dimension. So what is meter? That's what? Length. Then what is seconds per second square? That's what? T. Second is t. Then that's going to be t raised to the power of minus 2 times what? L again. So if I simplify this now using indices, so this is going to be m, then L times L, that's what? L square, then t raised to the power of minus 2. Thank you.